With all its branches, the Erie Canal is 9 times longer than the Panama Canal.
Albany, New York, 1831. The directors of the Erie Canal Corporation gathered in their marble headquarters to review the year's receipts. $2.3 million in tolls, and the canal had been open just 6 years, already printing money faster than they could count. When a junior clerk mentioned rumors about a steam locomotive hauling freight near Baltimore, the room erupted in laughter. Within 15 years, the toy would erase them completely. They controlled America's only efficient bulk freight system, but failed to see exponential improvement racing toward them, like a freight train they couldn't hear coming. The Canal's triumph. The Erie Canal was the moon landing of its era. When it opened in 1825, it accomplished something most engineers thought impossible. It carved a navigable waterway across 363 miles of wilderness, connecting the Great Lakes to the Atlantic Ocean. The project had taken 8 years, cost $7 million, and required the invention of entirely new construction techniques. Nobody in America had built anything like it. There were no textbooks, no precedents, no experts. The engineers were farmers and merchants who taught themselves hydraulic engineering through trial and error. They invented a waterproof cement that could set underwater by experimenting with limestone. They designed locks by studying European drawings and improving on them. They blasted through solid rock using black powder in ways that terrified everyone involved. When workers hit the malaria-infested Montezuma Swamp, 1,000 men fell sick. They kept digging. When the first barges floated from Buffalo to New York City in October 1825, the celebration lasted for days. Governor DeWitt Clinton poured a barrel of Lake Erie water into the Atlantic Ocean in a ceremony called the Wedding of the Waters. The symbolism was not subtle. They had married the interior of the continent to the global economy. The economic impact was immediate and staggering. Before the canal, shipping a ton of freight from Buffalo to New York City cost $100 by wagon and took 3 weeks. The canal dropped the cost to $10 and the time to 8 days. It was a 90% cost reduction overnight. The math was so extreme that people initially did not believe the numbers. Farmers in Ohio, who had been trapped by geography, watching their surplus wheat rot because transport costs exceeded the value of the grain, suddenly had access to eastern markets. They could grow for profit instead of subsistence. Towns that had been frontier outposts became commercial centers within a year. New York City exploded in size as cheap grain flooded in from the interior. The population doubled in a decade. The port became the busiest in America as European goods flowed west and American grain flowed east through the same canal. Buffalo transformed from a village of a few hundred people into a booming city of over 18,000 by 1840. Canal towns like Syracuse and Rochester emerged from nothing. The canal created wealth so fast it seemed like alchemy. The returns on investment were almost obscene. The state of New York had borrowed $7 million to build the canal, an amount so large that critics called it Clinton's ditch and predicted financial ruin. They were catastrophically wrong. By 1835, just 10 years after opening, the tolls had completely paid off the debt. The canal was now pure profit. Every barge that passed through the locks was printing money for the state and the private companies that controlled sections of the waterway. The annual toll revenue reached $2.3 million by 1831. That was more than the entire construction cost being recouped every 3 years in perpetuity. This success spawned an explosion of canal construction across the young nation. Pennsylvania built a canal system connecting Philadelphia to Pittsburgh's at a cost of over $10 million. Ohio constructed a network linking Lake Erie to the Ohio River. Indiana borrowed $13 million for an ambitious canal system. Illinois, Virginia, and Maryland all launched massive canal projects. By 1840, America had over 3,000 miles of artificial waterways. Investors poured millions into canal stock, confident they were backing the future of American commerce. Canal bonds were considered safer than government securities. The mania was total. The canal companies developed a culture of absolute confidence bordering on arrogance. They had solved the fundamental problem of American geography. The Appalachian Mountains and vast distances that had made the interior inaccessible were now conquered. Water transport was cheap, reliable, and physics made it unbeatable. A horse pulling a wagon on a dirt road could move 1 ton. That same horse pulling a barge on a canal could move 50 tons. The mathematics were immutable. carved into the laws of nature. Nothing could challenge water's fundamental efficiency. Friction on water was a fraction of friction on land. This was not opinion. This was physics. This confidence was reinforced by the massive sunk costs. Canal construction was brutally expensive. You had to dig the channel, build the locks, construct the aqueducts, and maintain the entire system. The Erie Canal alone required 83 locks to manage elevation changes. Each lock was a complex piece of engineering featuring massive wooden gates that required constant maintenance, replacement, and skilled lock keepers. The companies that had made these investments were certain they had built infrastructure that would dominate for generations. You do not spend $7 million or $10 million or $13 million on something temporary. The canal owners also enjoyed political power that matched their economic dominance. They had close relationships with state legislatures that had funded the projects through bond issues. They employed thousands of workers, from lock keepers to boat builders to the mule drivers who walked the tow paths. They controlled the choke points of American commerce. When legislators proposed charters for early railroad companies, canal interests often blocked them or ensured the rail lines could not compete with established water routes. The political fix was in. By 1835, the canal system looked invincible. The network was growing. Profits were soaring. The technology was proven. The political power was secure. And then a strange iron contraption on wooden rails started making noise in the background. The canal men heard it. They just were not listening. The absurd Challenger. The early locomotive was not an impressive machine. It was loud, dirty, dangerous, and unreliable. The first American-built locomotive, the Tom Thumb, famously lost a race against a horse in 1830. When canal owners saw these machines, they saw confirmation of their superiority. Water transport had been refined over thousands of years. These steam contraptions were experiments, curiosities for wealthy tinkerers who had more money than sense. The technical limitations seemed insurmountable. Early locomotives constantly broke down. Boilers exploded without warning, sending scalding steam and metal fragments into crowds of onlookers. The boiler explosions were so common that insurance companies refused to cover early railroad operations. Tracks made of wood topped with iron straps would curl up and pierce through the bottom of cars in what engineers grimly called snakeheads. Workers died impaled on their own rails. The ride was rough enough to shake cargo apart. Barrels split open. Crates disintegrated. Delicate goods arrived as expensive piles of debris. Sparks from the smokestack set nearby buildings on fire and ignited the wooden cars themselves. Some early railroads required passengers to sign waivers acknowledging they might burn to death during the journey. The machines were so unreliable that most early railroads kept horses on standby to pull the cars when the locomotive inevitably failed. This happened often enough that some railroads spent more time using horsepower than steam power. The locomotives that did run consumed fuel at rates that seemed economically absurd. A single engine might burn through a cord of wood every hour. On long routes, this meant stopping every few miles to reload fuel, turning what should have been express transport into a series of lengthy delays. Canal operators watched this inefficiency with satisfaction. Their barges floated for free, powered by horses that could graze along the towpath. Canal operators produced detailed analyses proving railroads could never compete economically. They pointed out that laying track was expensive, requiring the purchase of land and enormous quantities of iron. The cost per mile to build a railroad was 3 to 4 times higher than digging a canal. Canals used water that flowed freely. Rail required constant fuel purchases that would bankrupt any company trying to move bulk freight. Locomotives needed expensive maintenance and skilled engineers who commanded high wages. Canal barges were pulled by horses that ate cheap hay and could be replaced easily when they wore out. The math, they insisted, made rail transport fundamentally uneconomical for bulk freight. The safety concerns seemed to vindicate canal owners' skepticism. Early rail accidents were spectacular and deadly. Locomotives derailed on curves, tumbling down embankments and crushing passengers. Boilers exploded, killing engineers and passengers in horrific fashion. In 1833, the world's first railroad tunnel collapsed in Pennsylvania, trapping workers under tons of rock. Newspapers published detailed accounts of these disasters with gruesome illustrations. These catastrophes made headlines while canal boats floated peacefully along established routes. the worst danger being an occasional horse stumbling on the towpath. Why would any rational shipper choose a dangerous, unreliable technology over proven water transport? Physical limitations also seem to protect the canals. Early locomotives could barely climb grades. Anything steeper than a 2% incline required double engines or cable-hauled inclined planes. A canal boat could navigate gentle elevation changes through locks, a proven technology that had worked for centuries. A train required either a level route or expensive tunneling and bridge work that multiplied construction costs. The Allegheny Mountains, which the Pennsylvania Canal conquered through an ingenious system of inclined planes and stationary steam engines, appeared to be an impenetrable barrier to rail. Geography itself seemed to be on the side of water transport. Mountains did not move. Rivers followed gravity. These were laws of nature that no amount of steam pressure could overcome. Canal companies watched the early railroad experiments with amused tolerance. The Baltimore and Ohio Railroad, chartered in 1827, was building a line to reach Western markets. Canal operators did not consider it a threat to their dominance. They saw it as a minor competitor that might capture some passenger traffic, people willing to pay premium prices for speed and willing to risk their lives for convenience. But bulk freight, coal, grain, lumber, that would always move by water. When the B&O struggled with technical problems and financial difficulties through the 1830s, canal men felt vindicated. The cultural mockery was relentless. Newspaper editorials in canal towns derided the railroad as a foolish waste of money. Investors who backed rail projects were called dreamers, throwing money away on impractical schemes that violated common sense. Canal company presidents gave speeches explaining why water transport was ordained by nature to be superior. They produced calculations showing that even if railroads somehow improved, they could never match canal efficiency. Physics was physics. Economics was economics. The railroad advocates were fighting both. One famous incident captured the canal men's attitude perfectly. In 1831, the president of a major canal company was invited to inspect a demonstration of a new locomotive. He watched it huff and puff along a short stretch of track, belching smoke and sparks, the screech of metal on metal making conversation impossible. When it finally lurched to a stop, he turned to the railroad promoter and said, "Very impressive. When you can make it float, let me know." The crowd of canal investors laughed. The railroad man did not laugh. He just wrote down numbers. The future laughed back, because while canal men were laughing, a few people were calculating, and the numbers they were seeing told a very different story than the one canal companies wanted to believe. The mathematics of speed. The canal companies made one catastrophic error in their analysis. They calculated cost per ton-mile, but ignored the value of time. This blindness would destroy them. Here is the equation that doomed water transport. A canal boat moved at roughly 4 miles per hour when conditions were perfect. Realistically, accounting for locks, water levels, and weather delays, average speed was closer to 2 miles per hour. The Erie Canal ran 363 miles. That meant a one-way journey took about 8 days under good conditions. Round trip was 16 days minimum. A locomotive in 1830 traveled at maybe 15 miles per hour with freight. Primitive, barely faster than a canal boat. But here is what canal owners failed to see coming. The locomotive was improving exponentially, while the canal boat was already optimized. By 1840, good locomotives could maintain 25 miles per hour with freight. By 1850, express freight trains were hitting 40 miles per hour. Do the math. At 40 miles per hour, the same route that took a canal boat 8 days took a train less than 10 hours. But speed creates a multiplier effect that canal companies completely failed to anticipate. If you are a shipper, that speed difference means you can turn your capital over faster. Your goods reach market while demand is still high. Your money is not tied up in inventory floating slowly across the state. The compound effect was devastating. A single locomotive could make the Buffalo to New York run and back in under 2 days. That same locomotive could complete the circuit 8 times in the 16 days a canal boat took for one round trip. One train was doing the work of 8 boats. Suddenly, the cost equation looked very different. Even if the per-mile cost was higher, the utilization rate made rail far more economical. Then came the weather factor. Canals froze. Every winter, from November to April, the entire northern canal system shut down completely. Shippers had to stockpile goods or find alternative routes. Railroads ran year-round. This was not a minor advantage. It meant rail had a 5-month monopoly every year. Shippers who needed reliable winter transport had no choice but to use trains. Once they discovered rail's speed advantage, many never went back to canals even in summer. The network effects accelerated rail's advantage. Each new rail line connected to existing lines created a growing web of instant connections. Canals were fixed routes with fixed terminals. Railroads could build junctions, create through routes, and connect any 2 points with sufficient demand. By 1850, you could ship freight from Boston to Chicago entirely by rail, switching between different railroad companies at connection points. Canal shipping required multiple transfers between different waterways, each adding time and cost. Rail also solved the tyranny of geography that had always limited water transport. Rivers flow downhill. Canals required enormous engineering to cross watersheds. The Pennsylvania Canal needed to haul boats over the Allegheny Mountains using a system of inclined planes and stationary steam engines. It was an engineering marvel, but also a bottleneck. Railroads could cross the same mountains with steady grades, no transfers required. The route that took Pennsylvania's canal system days could be covered by rail in hours. The flexibility advantage became clear as rail networks expanded. A railroad could add a spur line to serve a new factory or mining operation in months. Extending a canal to the same location would take years and millions of dollars. Railroads could adjust routes based on demand. Canals were permanent, inflexible arteries that could not adapt to changing economic geography. By 1845, sophisticated shippers were running calculations that terrified canal investors. For high-value freight, where speed mattered, rail was already cheaper when you factored in the time value of money and inventory costs. For bulk freight like grain and coal, where canals still had a cost advantage, that advantage was shrinking every year as locomotives improved and rail companies built economies of scale. The canal owners saw these calculations too. They saw shippers beginning to defect. And that is when they finally realized the toy train was not a toy. It was a guillotine. The breaking point. The moment of reckoning came differently for different canals, but the pattern was always the same. First, the passenger traffic disappeared, then the high-value freight followed. Then the bulk shippers started asking for discounts. By the time canal companies slashed tolls, it was already too late. The Pennsylvania Mainline Canal System provides the clearest example of collapse in slow motion. The system had opened in 1834 at a cost of over $10 million. It was a marvel of engineering, connecting Philadelphia to Pittsburgh through 395 miles of canal and portage railroad. The state was collecting healthy tolls through the late 1830s. Then the Pennsylvania Railroad received its charter in 1846. At first, the canal operators were not worried. The railroad would take years to build across the mountains. The canal had a head start and established infrastructure, but the railroad builders learned from earlier projects. They used better steel rails, more powerful locomotives, and improved civil engineering. By 1854, through trains were running from Philadelphia to Pittsburgh entirely on rail. The impact on canal traffic was immediate and catastrophic. In 1854, the Pennsylvania Canal System collected $1.2 million in tolls. In 1855, tolls dropped to 900,000. In 1856, they fell to 600,000. The decline accelerated every year. By 1857, the state was operating the canal at a loss. The same waterway that had been called a license to print money was burning taxpayer dollars to stay open. The canal companies tried desperate measures to compete. They slashed tolls by 50%, then 75%. This did not bring traffic back. It just meant they were losing money faster. Shippers who had tasted rail speed did not want to go back to slow water transport even at bargain prices. Time had become more valuable than the cost savings. Some canal companies tried to improve speeds by using steam-powered tugs instead of horses. This helped marginally, but could not overcome the fundamental limitations of water transport. Canals still froze in winter. They still required locks that created bottlenecks. They still could not match rail's flexibility in reaching new markets. The political response revealed how quickly power shifted. Through the 1830s, canal interests had dominated state legislatures. By the 1850s, railroad companies were the new power brokers. State governments that had invested millions in canals now began investing in railroads. The Pennsylvania legislature, which had built its canal system with public money, sold it to the Pennsylvania Railroad in 1857 for $7.5 million. The state took a loss of over $3 million on its investment. The railroad bought the canal primarily to shut it down and eliminate competition. The Erie Canal fought longer than most because of its superior geography and lower operating costs. But even the Erie could not escape the fundamental mathematics of speed. Through the 1840s, Erie tolls continued to grow as Western grain flooded east. But after 1850, when rail lines connected Buffalo to New York City, canal tonnage began a long, steady decline. The Erie never completely died like other canals, but it ceased to be the dominant freight artery it had been. The human cost was staggering. Canal. Towns that had boomed in the 1830s withered in the 1850s. Port cities on canals watched their commerce dry up as railroads created new commercial centers at rail junctions. Thousands of canal workers, boat builders, lock keepers, and associated tradesmen lost their livelihoods as traffic vanished. The same economic transformation that had created these jobs through canal construction now destroyed them through rail competition. The financial destruction rippled through the economy. Investors who had poured money into canal stocks and bonds watched their investments become worthless. State governments that had borrowed millions to build canals found themselves saddled with debt for infrastructure no one used. The Panic of 1857, one of the worst financial crises of the 19th century, was partly triggered by the collapse of canal investments as railroads rendered them obsolete. By 1860, the question was no longer whether railroads would replace canals. The question was how fast the remaining canals would die. The collapse. The speed of obsolescence was breathtaking. Infrastructure that had taken decades to build and cost tens of millions of dollars became worthless in less than 20 years. The scale of capital destruction was unprecedented in American history up to that point. The Ohio and Erie Canal opened in 1833, connecting Lake Erie to the Ohio River. It was called the Artificial River, a 309-mile waterway that made Cleveland and Columbus commercial centers. Through the 1840s, it carried massive freight volumes. By 1861, traffic had fallen by 75%. The canal continued operating at diminishing volumes until the Great Flood of 1913 finally destroyed sections beyond repair. By then, it was already a ghost, used primarily by a few die-hard boat operators who could not or would not adapt to rail. The Chesapeake and Ohio Canal suffered an even sadder fate. Construction began in 1828 with the goal of connecting Washington, D.C. to the Ohio River. It never made it. The canal only reached Cumberland, Maryland, 184 miles from D.C., and by the time that section opened in 1850, railroads had already made it obsolete. The C&O operated for another 70 years, limping along with coal traffic that railroads did not want, but it never made a profit. It never recouped a fraction of its construction cost. It stood as a monument to how quickly technological superiority could render massive investments worthless. The Indiana Canal system collapsed so completely that sections were literally abandoned mid-construction. Indiana had chartered an ambitious canal network in 1836 during Canal Mania. The state borrowed $13 million, an enormous sum that represented Indiana's entire credit capacity. By 1840, with canals only partially complete, it became clear railroads would make them unprofitable. Indiana defaulted on its bonds. The canal sections that were finished operated briefly, then closed. The state spent decades paying off debt for infrastructure that never worked. The pattern repeated across America. Canal after canal closed, was sold for pennies on the dollar, or was bought by railroad companies that shut them down to eliminate competition. The few canals that survived did so only by finding niche markets railroads did not want. The Delaware and Hudson Canal carried coal from Pennsylvania mines to New York until 1971, but it was a relic, not a competitive freight artery. What made the collapse so total was that canal companies could not adapt. Their infrastructure was fixed. You cannot easily relocate a canal or add new routes. Railroads were built incrementally, adapting to demand, connecting new mines, factories, and cities as they developed. Canals were all or nothing investments that became immovable barriers when economic geography shifted. The maintenance burden accelerated the death spiral. Canals required constant upkeep, Locks needed repair, banks needed reinforcement, channels needed dredging. When traffic declined, toll revenues fell, but maintenance costs remained fixed. Canal companies found themselves spending more on upkeep than they collected in tolls. This created a vicious cycle. Deferred maintenance made canals less reliable, driving away remaining traffic, reducing revenues further. Some canal companies tried to convert to rail. The Chesapeake and Ohio Canal Company sold sections of its towpath to railroad builders. The Pennsylvania Canal system was literally filled in and turned into railroad right-of-way. This was the ultimate admission of defeat. The infrastructure that was supposed to last centuries was actively destroyed to make room for its replacement. The cultural shift was equally dramatic. In 1830, canal engineers were the celebrities of the technical world. By 1860, railroad engineers had displaced them entirely. Young men who once dreamed of building canals now wanted to design the locomotives. The technical journals that had devoted pages to canal construction techniques now focused exclusively on rail. The canal era did not slowly fade. It was violently overwritten. The few canal advocates who remained became bitter defenders of a lost cause. They published pamphlets arguing that society had been too quick to abandon water transport. They pointed out that canals were more fuel efficient, less polluting, and safer than railroads. They were correct on all counts. But none of it mattered. Speed had triumphed over every other consideration. In a commercial economy where time was money, the slower technology lost regardless of its other virtues. By 1870, the canal era was effectively over. Miles of waterways that had hummed with commerce sat silent, slowly filling with weeds and silt. Lockkeeper houses stood empty. Canal towns that once thrived became economic backwaters. An entire industry had been erased in a generation. The new order. The railroad victory was so complete that by 1870, most Americans under 30 had never known a world where canals mattered. Rail had become the default, the natural way of moving goods and people. The canal era had become a historical curiosity, something grandparents remembered. The lesson was brutal but clear. In technology competition, the winner often does not just beat the loser, it erases them so thoroughly that the previous system becomes unimaginable to the next generation. The canal owners' fundamental error was assuming their infrastructure created a permanent moat. They believed the massive capital investment and physical presence of canals would protect them from competition. They learned that infrastructure advantage only matters if the infrastructure remains relevant. The locomotive did not need to be better at everything. It only needed to be better at the things customers valued most. Speed mattered more than cost per ton mile. Flexibility mattered more than energy efficiency. Year-round operation mattered more than the elegance of water transport. The railroads won by redefining which metrics mattered. The canal owners also failed to recognize exponential improvement. They saw early locomotives as they were, not as they would become. This is the classic innovator's dilemma. Established players dismiss new technology because its current form is inferior. They fail to extrapolate the improvement curve. By the time the new technology reaches parity, it is already too late to respond. The economic destruction was necessary for progress. Those abandoned canals and bankrupt canal companies represented capital that was reallocated to railroads. The workers who lost canal jobs found work building rail lines. The towns that withered on canal routes were replaced by rail cities. Creative destruction is creative, but the destruction is real and painful for those caught in it. The parallels to modern disruption are impossible to ignore. How many established industries today are making the same mistake canal owners made? They see new technology, find it inferior by their existing metrics, and dismiss it. They do not see the improvement curve accelerating. They do not recognize that customer priorities might shift to favor the new technology's strengths. The canal owners ridiculed the locomotive because at that moment, ridicule seemed justified. The early trains were inferior by every measure canal companies cared about. What they missed was that the measures were about to change. Speed, flexibility, and year-round operation would soon matter more than low cost per ton mile. By the time they realized their error, the industry they dominated was already dead. Today we live in a railroad world, or more accurately, we live in a world where whatever came after railroads dominates. Because, eventually, something faster and more flexible replaced even the mighty railroad for some applications. The cycle continues. The lesson endures. Dominance is temporary, infrastructure is not a moat, and the surest way to be disrupted is to laugh at the disruption while it is still small enough to laugh at. The Erie Canal still exists, maintained as a historic waterway and recreational resource. Pleasure boats float where freight barges once dominated American commerce. It is a beautiful monument to dead certainty, a reminder that every invincible industry is one breakthrough away from irrelevance.